In this lecture, we will deal with ionic equilibrium, in which we will talk about various theories which were proposed to explain the properties of acids and bases, the definition of strong electrolytes and weak electrolytes, Ka, Kb value, Ostwald dilution law, and buffer solutions. Now, to start with, first we go to the basic theory which was proposed by none other than Arrhenius. According to him, acid is a substance which, when added to water, increases the concentration of H plus ion. Please remember, this definition is very important. Once HCl is added to water, it is furnishing H plus ion into the solution, whereas base is hydroxide ion donor, which is increasing the concentration of OH minus. If you observe the definition properly, it says that acid increases the concentration of H plus ions. Please remember, if it is saying increases the concentration of H plus ion, inherently it is saying that already there is some H plus in water, that is, Pani undergoes dissociation, that is self-ionization. This we need to underline and remember. Now, please remember, according to Arrhenius, base acts as hydroxide donor. You take NaOH, or you take calcium hydroxide, or you take aluminum hydroxide. Effectively, they generate OH minus in solution. Now, according to this, what will be neutralization? H plus plus OH minus will give H2O liquid. Now, please remember, if Arrhenius theory was able to explain every property, people were not in need of any new theory. But please remember, there were few points that which were not explained by Arrhenius theory. For example, if you take calcium oxide, this is metal oxide by nature and it is basic. It is basic. Please remember, it doesn't have any OH minus in the formula, but once it is added to water, it will be, the solution will be basic. This was not properly explained by Arrhenius theory, though people were looking for more theories which could explain all the observations. Please remember the definition. According to Arrhenius, acid increases the concentration of H plus ions once it is added to water. Base is something which increases the concentration of OH minus ions once it is added to water. This you need to understand and remember. But Arrhenius theory could not explain every observation. That is, one of them was calcium oxide, once it is added to water, the solution is basic. But this doesn't contain any OH minus in the formula. So people were in need of a new theory which could explain all the observations. Now, the second theory that which we consider is Lowry-Bronsted theory. According to this, acid is a substance which when added to water, that is H plus donor, and base is H plus acceptor. For example, here a very good thing to understand and appreciate is HCl is acid, and please remember, and Pani is acting as base. Now, why we are saying this is HCl is losing, if you see the conversion, HCl is becoming Cl minus, that means it's lost a proton, that means it has donated a proton. That means HCl is acting as this. Now please remember, this is called conjugate base. Please remember. Now H2O accepted a proton from HCl to form conjugate acid. Now, according to Arrhenius, acid donates H plus. So please remember, according to Lori Bronsted or Arrhenius, acid is H plus donor. There is no problem whatsoever. But the context of base changes because according to Arrhenius, base is hydroxide donor, whereas according to Lori Bronsted, base accepts as H plus acceptor. Now, please remember, what are conjugates? Please remember, conjugates are something which differ by a proton. Conjugates, they differ by a proton. A very important path to remember. For example, if I take H2SO4, if it dissociates into H plus and HSO4 minus, these two they differ by a proton, so they will be called as conjugates. HSO4 minus dissociates into H plus plus SO4 2 minus. These two they differ by a proton, so they are conjugates. They are conjugates. But if you take H2SO4, if you take H2SO4 and SO4 2 minus, they differ by two protons, so they are not conjugates to each other. Please remember, they differ by a proton. Now, we have seen the acid part, the base part, and the conjugate part. Now, this is according to Lori Bronsted. Once again, I am repeating, there is no difference in context of an acid with Arrhenius and Lori Bronsted. According to both theories, acid furnishes H plus ion in solution. Now, according to Arrhenius, base is hydroxide donor, whereas according to Lori Bronsted, it is H plus acceptor. Now, we go to the next concept or the theory, that is Lewis. Bit tricky, we'll explain it. According to this, acid is a substance which accepts electron pair, and base is a substance which donates electron pair. Now, we need to explain this in a better way. Now, first, to donate, please remember, to donate, just a moment please. Please remember, to donate, first the atom should have octet. The atom should have octet. हम क्लास में बोलते हैं खुद की समृद्धि उसके बाद दुनियादारी. That means first you should have octet and then only you'll be able to donate. Now, if every atom has octet, least electronegative will donate more. Least electronegative will always donate more. Now, we take a standard example, ammonia, boron, trifluoride. Please remember, if you know the Lewis dot structure of ammonia, N के ऊपर एक चोटी रहेगा, and 3 hydrogens. Please remember, this N has octet, that is 8 electrons. If you see boron, B, F or F, B doesn't have octet. So please remember, this is going to act as electron donor, that is Lewis base. This is going to act as electron pair acceptor, that is Lewis acid. Now, generally, how do we represent it is by an arrow mark where the tip of the arrow is showing Lewis acid and the base of the arrow is showing Lewis base. Generally, this sign represents a special case of a covalent bond called coordinate covalent bond, where the shared pair of electrons are donated by one atom or group. देखो बेटा, if it is a normal covalent bond, हम क्लास में ऐसा बोलते हैं, तेरा एक मेरा एक हमारे दो इलेक्ट्रॉन्स, बट इसमें मेरे दो हमारे दो ऐसा आप शॉर्टकट छोटा सा बना के आप याद कर सकते हो. Now, Lewis base, a point to be underlined, electron pair donor, whereas Lewis acid electron pair acceptor. And the bond will be a special case of a covalent bond called coordinate covalent bond, where the shared pair of electrons are donated by one atom or group. Now, we go to the next aspect, that is hydroacids. Please remember, acidic H is linked to the second element directly. Means in the formula it's quite evident you have more electronegative atom and there is one hydrogen. They are linked directly, so they dissociate. For example, if you take HF, it is going to dissociate into H plus and F minus. They are called hydroacids. The next definition generally that which we use is oxyacids, which contain an oxygen atom. Please remember, here the acidic H is linked to an oxygen atom. These are the structures of basically Lewis dot structures of H2SO4. Please remember, and sorry, there's a technical problem, and HNO3. Sorry, doesn't want to write the pen. HNO3. Now please remember, here I have represented one coordinate covalent bond. No, sir, I don't like coordinate covalent bond, so you can represent it like this also. N double bond O plus O minus. This is neutral and this is charged stuff. Effectively, both diagrams are same. Here, बहुत बच्चे मुझे बोलते हैं सर थोड़ा confusion आ रही है, थोड़ा बताओ ना गाउट टाइप. तो प्लीज रिमेंबर बेटा, अपन को ये बात पता है कि if you take H2SO4, sorry, if you take H2SO4, it dissociates into 2H plus and SO4 2 minus. Now, if I remove these hydrogens, please remember, if I remove this hydrogen as H plus, the diagram will look like this. Sulfate S double bond O, double bond O, O minus and O minus. Likewise, if I remove H from HNO3, it will look like H plus plus NO3 minus nitrate ion. The structure will look like this. N double bond O, O minus, O minus. There is an O here. Now please remember, nitrogen is having 4 bonds. It will carry a charge plus. It will carry a charge plus. So please remember, oxyacids Just a moment. Oxyacids, they contain oxygen in their formula, and the acidic H is linked to that oxygen atom. Whereas in hydroacids, acidic H is directly linked to the second element. Generally, it will be more electronegative element. For example, beta, you can see here HF, Cl, Br, I, S. These are all more electronegative atoms when compared with hydrogen. So, if you remember electronegativity, so it helps you to predict few properties better. So, in this, we have tried to explain first Arrhenius concept, where acid donor, acid is H plus donor when added to water, base is hydroxide donor. Then we went to Laurie Bronsted, where we said the context of acid is same as Arrhenius, but the concept of base is here it acts as H plus donor. And we have explained the concept of, please remember, conjugates which differ by a proton. Very important aspect. These two here, they differ by a proton, whereas these two also differ by a proton, and these two, they differ by two protons, so they are not conjugates. Now, the next aspect was Lewis acid and Lewis base. Please remember electron pair acceptor and electron pair donor. Here we have represented the bond by arrow mark. Lewis base, here it is acting as electron pair donor, please remember, whereas it is acting as electron pair acceptor. If you remember the conditions octet and Lewis dot structure properly, please remember in BF3 it doesn't have octet, so it acts as Lewis acid, and this is exception to our octet rule also. Hope you understood the basic theories which explain the properties of acid and base. We will see a few practice questions. First one, what is the conjugate base of the following? For this, we need to write the balanced equation of these components with water. For example, if we take H3PO4 plus H2O gives H3O plus H2PO4 minus. Please remember, in this it is acting as an acid, or please remember they are asking about conjugate base. Means इसी का ये वाला part, this will be the base. Please remember these two will be conjugates because they differ by a proton. Now ये बात बहुत important है कि this is acting as an acid. So here it is acting as a base. But please remember, इस acid का conjugate base will be this guy because they differ by a proton. Now same आपने ammonia लिया. Please remember, ammonia plus H2O gives ammonium ion plus OH minus. Now, please remember what is the conjugate base. Please remember, which is formed after losing one H plus is called conjugate base. Now here there is one more reaction that which we need to write, that is ammonia plus H2O gives H3O plus NH2 minus. Please remember, here it is gaining one proton, here it is losing one proton. So this guy will be conjugate acid. The question is asking about conjugate base. So this guy will be conjugate base. Please remember, so this will be our equation to be considered. Both are conjugates, they differ by one proton. So for ammonia, the conjugate base will be something which is formed after losing a proton. This is NH2 minus. This is called amide ion, maybe you can check. Now, please remember the next one is H3O plus. Please remember H3O plus H2O equilibrium, H3O plus H2O. So this will be the acid, this will be the conjugate base. Now same आपने methanol लिया. Please remember, don't confuse it with daru. This is daru का भाई methanol. Please remember CH3OH plus H2O equilibrium, equilibrium. You will have H3O plus CH3O minus. Please remember this is called methoxide ion and this is methanol. Please remember this guy is losing a proton to form this. So this will be the conjugate base. So whenever anyone asks you a conjugate base, first write the reaction with water. Initial prani, once it loses H plus. Please remember, anything which loses after it loses one H plus, the prani which is formed is considered as conjugate base. Now, for example, if the question asks you about conjugate acid, so what we need to do is, first we need to write the equation H2O plus H minus equilibrium will give OH minus plus HF. See, these two, they differ by a proton, so this will be my conjugate acid. This will be my conjugate acid. Now, PO4 3 minus plus H2O equilibrium will give OH minus plus HPO4 2 minus. You can state something like this. These two again they differ by a proton. The plus means something which gains a proton will become the corresponding conjugate acid. Now with ammonia. Please remember earlier we wrote that equation. H2O plus ammonia equilibrium will give ammonium plus OH minus. The first equation here, these two are the conjugates which differ by a proton. Now, F minus का conjugate acid आएगा HF और PO4 3 minus का आएगा HPO4 2 minus. अमोनिया का conjugate acid आएगा NH4 plus. Now, we see a bit more tricky one, that is, consider the following reactions and arrange the Bronsted acids. Please remember, what is a Bronsted acid? Bronsted acid is something which can lose a proton that appear in the equation in the order of decreasing acid strength. देखो बेटा, सबसे पहले H2PO4 minus. Here H2PO4 minus is becoming H3PO4. That means this guy gained a proton. म्हणजे this is acting as base. Here this party is acting as acid. इसका conjugate acid ये है. Please remember this guy is my conjugate base. Now in this equation HCN is acting as an acid and OH minus is acting as base. On the right hand side, this is my conjugate base, this is my conjugate acid. Now, please remember, if H3O plus is becoming H2O, that means it lost one proton. Now, if you compare the acidic strength of these two prani, If this reaction is not coming piche, means H3O plus can lose proton better than H3PO4. Now, if you see this reaction, what to do, what we can infer is HCN can act as a good proton donor than H2. That's why it's not coming pitch. Now, please remember, if you write the order, that is the decreasing order of their acid strength, it will look something like this. H3O plus greater than H3PO4 greater than HCN greater than H2O. Now, please remember, we have done this order based upon the data given in the question. Please remember, first they said that H3O plus is reacting with H2PO4 minus to form H3PO4. That means H3O plus or H3PO4, who is dissociating? None other than H3O plus. Between HCN and H2O, who is dissociating first? HCN. That's why the order came up like this. Hope you understood the concept of conjugate, how to predict conjugate base, how to predict conjugate acid, and how to predict relative Bronsted acid strength from the given species from the equations given. Thank you.